All right, so the triangle one looks like this. So it has the congruent triangle things on the back, this on the front, and the other one looks like this. So you need both of them out. That's what we're starting with today. All right, so last week we discussed all the different properties of quadrilaterals. So we talked about the different properties, where they kind of fall in the hierarchy or their family tree. All right. Now we're getting into proof land, meaning we know what makes those shapes. Now we're going to prove that they are that based off of certain things that we're given and what we have to show. Now, before we do that, we're going to review what the only type of proofs that you guys should have seen last year, which was triangle congruence proofs. All right, so in Math 2, the proof part that they have is in triangle congruence. With us, it's quadrilaterals. So we're going to go through the triangle stuff first because that will help us with the quadrilateral aspect. All right, so on the day that you guys had all those, the PSATs and stuff, I had you guys work through those packets where you guys were working on the triangle congruence postulates, so side, 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 angle, all that loveliness. So let's just go through these very quickly. All right. So first one. So we're on the back side of that yellow paper. So the back side of the yellow graphic organizer, or the gold one. So SSS, what does that stand for? Side, side, side. So in other words, if all three sides of two different triangles are congruent to each other, the two triangles are congruent. So for example, let's say this was ABC, and let's say this was DEF. All right, and then AB was congruent to DE, BC was congruent to EF, and AC was congruent to DF. Since all the corresponding pairs, or in other words, the sides that look like they could be the same sides, are congruent to each other, then we can say that triangle ABC is congruent to triangle DEF. Yep.
I don't have that yellow.
All right. What about SAS? What does that mean? Side, angle, side. So again, if I had triangle A, B, C, and then D, E, F, side, angle, side would be when we have two corresponding sides that are congruent, or two sets of corresponding sides that are congruent, and then the angle in between those two sides are congruent. So the way I think about it is that if I literally went in order of what's congruent all the way around, so like let's say I start with this side here, it'd be side, angle, side, side, angle, side. All right. So we could say those triangles are congruent because of side, angle, side. Now, what does ASA stand for? Angle, side, angle. Now, be careful with ASA because it's confused a lot with AAS. All right. So the difference between the two is angle, side, angle. Again, if I had ABC and DEF. Angle, side, angle. So let's say that angle A was congruent to angle D because that's the corresponding set. And angle C was congruent to angle F because those are its corresponding pairs. This would be angle, side, angle if the side that's in between those two congruent angles. So in other words, it's the side that both angles are used to make those angles, or that both angles touch. If that side is congruent, then it's angle, side, angle. So in other words, if both angles touch that congruent side, it's angle, side, angle. If it doesn't, it's probably our next one, which is what? AAS. Angle, angle, side. So angle, angle, side. All right. So again, A, B, C, and D, E, F. Now, angle, angle, side, let's say A and D were congruent, and then C and F were congruent. Angle, angle, side means that the side isn't between the two congruent angles, it's only next to one of the congruent angles. So do you see how this side is not between the congruent angles, whereas up here it is? That's the difference between the two. That's the one that I see most people switch up a lot. And then lastly, hypotenuse leg. Hypotenuse leg is the only form of SSA that works. All right, because I typically say you don't want ass in class. All right, so the only way it works is if it's a right triangle. So typically this means you cannot prove that the triangles are congruent. The only way you can is if it's by hypotenuse leg. So it has to be a right triangle, and the hypotenuse of both triangles are congruent, as well as a leg of both triangles are congruent. So this was ABC and DEF. The hypotenuse, or the side across from the right angle, is congruent, as well as another one of the sides. And that's called hypotenuse leg. So that's the only form of SSA that works. Every other form of SSA, if it's not a right triangle, it doesn't work. Now, one last thing to note with this is that after you prove congruent triangles, you can then say that corresponding parts of congruent triangles are congruent. All right, and that's called CPCTC for short. All that means is that once you prove the triangles are congruent, any other side or angle within those two triangles, as long as they're corresponding, you can say are congruent. So for example, if I go back up here, I already said that those two triangles were congruent. So now I can say that side AB is congruent to side DE because of CPCTC. Or I could say that angle A is congruent to angle D because of CPCTC. Because think about it logically, if we already showed that the whole triangle, so every piece of that entire triangle is congruent, wouldn't that mean the individual parts are congruent? If the entire triangles themselves are congruent? Isn't that true? Yeah. All right. Now, why are we going through this? Well, that leads into the proof aspect. So more often than not, that when you're proving congruent triangles, your last statement is going to be that the triangles are congruent by one of those postulates. All right, so SSS, SAS, AAS, or ASA, or HL. Now, if you look on the other side, we're going to now go through some different statements and reasons. Yes. Now, the other side that we're going to do, we're going to talk about the different statements and reasons, just some basic ones that you will possibly see in proofs. All right, so these are just some basic geometric statements and reasons that you'll see. All right, because remember, with a proof, you have the statement, which is basically you're saying, okay, these two pieces are congruent, or these two pieces are supplementary, or these two pieces are right angles, whatever. And then the reason. So your statement is your what, your reason is your why. So why can we say that they're congruent? Why can we say that they're supplementary? What theorem typically tells us that? All right. So I'm just going to go through some common ones that you will see a lot of. So the first one, if you have A equals B and you have B equals C, then A equals C. So that probably seems like a lot, but let's look at it this way. Let's say that 2 equals x. All right, so we know that 2 is equal to x. We also know that x is equal to y. So is it not true that 2 is equal to y? So if we know that 2 is equal to x, and we also know that x is equal to y, is 2 not also equal to y? Is that true? Yes. So we know that x is equal to 2, and we know x is equal to y. So by logic, y has to be equal to 2. All right. This is what we call the transitive or substitution property. Transitive. And basically all it means is that we take the common letters and we remove them and then set what's left equal to each other. That's all it means. So another example, and this is probably not even close, but let's say that I said that Zach is the same height as Wyatt and Wyatt is the same height as Julian. Is that not true that Julian is the same height as Zach?
Yes.
Yeah. All right. That's what that means. All right. Shh, 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 shh. The next property, this one actually has a diagram. This one actually has two. Boys. Shh. All right, so let's say this is A, B, C, D. So for this particular diagram, what I'm stating is that AC is congruent to itself. Why can I say that AC is congruent to itself? So we're typically looking at that like if we're proving two triangles are congruent. So we're proving the top and the bottom triangle are congruent to each other. Why can I say that AC is congruent to itself? So guys, if I look at the yellow triangle and the green triangle, AC is what between the two? It's what separates them, or it's the same side. So can we say that a same side is congruent to itself? Yeah. All right. We then have this diagram. So let's call this E, F, G, H, I. And I'm looking at this angle right here. I'm going to say that angle E is congruent to angle E. So I'm talking about the angle E of this little triangle versus the angle E of this big triangle. So in other words, angle E is in the same spot for both triangles. They're literally the exact same angle, so we can say that they're congruent to each other. This has a name. It's called the reflexive property. And all it's saying is that if it's the exact same side between two triangles or the exact same angle between two triangles, we can say they're equal to each other or equal to itself. It's also just a fancy way of saying that it shares a side or it shares an angle. Now, the next one, let's say I had two parallel lines cut by a transversal. All right, so remember also when we were doing your pre-ACT stuff, I had you guys looking at theorems with parallel lines. Okay. Let's say I had these two angles right here, angle 1, angle 2. What can I say about those two angles? What's true about those two angles? Are they congruent, supplementary, complementary? What do you think? They're congruent. Why are they congruent? What property tells us they're congruent? So look at their placement. First off, are they inside or outside the parallel lines? Inside. Are they on the same side or opposite sides? Opposite. So instead of opposite, we say the word, starts with an A. Yep. Alternate. So in other words, alternate interior angles are congruent in parallel lines. So we can say those two angles are congruent because alternate interior angles are congruent in parallel lines. Now let's say I have another set of parallel lines cut by a transversal. Let's say this is angle 1, this is angle 2. What's true about those two angles? They're same side interior, so what are they to each other? What's their relationship? Are they congruent, supplementary, complementary? So same side interior angles, that means that they're what to each other? Yep. Really, boys? So are they going to add to 180? Are they going to be equal to each other? What do you guys think? They're going to add to 180, or in other words, they are what? Supplementary. So in other words, angle 1 plus angle 2 is equal to... Yep. It's because same side interior angles are supplementary. Shh. Boys in parallel lines. All right. Now, let's say I had two lines that are crossing. And then I have these two angles here. So angle 1, angle 2. What can I say about those two angles? Uh-huh. Yeah. So what's true about those two angles? What's their relationship to each other? They're not adjacent. They're congruent because they're opposite each other. But what's the official name for them? What are these two angles called? Starts with a V. Vertical angles. Good. So we would say that vertical angles are congruent. Okay. What about if I have a line and I have some kind of ray here, and I have two different angles, so 1 and 2. What's true about those two angles? What's the relationship between those two angles, or what to each other? They're supplementary. So angle 1 plus angle 2 is equal to 180 degrees. Why? What's that called? I'll give you a hint. 2 words. First letter of each word is LP. So first word starts with an L, second word starts with a P. Something pair. Linear pair. So this is called a linear pair, meaning it's two angles on the same line and they're adjacent to each other. So a linear pair are supplementary. Now, let's say we had a line segment. Let's call it AB. Now let's say a line cut through it. Let's call that line L. And it just so happened that it cut through at the midpoint. Let's call it M. So first off, if a line cuts through another line at its midpoint, what's that line called? It's a what? Not a y-intercept. There's no graph. Well, it's an intercept, but I'm thinking more geometrically. Think about how the diagonals of a parallelogram relate to each other. So what's true about the diagonals of a parallelogram? They do what? Starts with a B. They bisect. All right. So this is called a segment bisector because it crosses a segment at its midpoint. So what's true about a bisector? What does it do? It splits it in half. So that means that AM is congruent to MB. So we can say that AM is congruent to MB. And what we could say, depending on what they gave us, is that it's the definition of a segment bisector. Or it's the definition of a midpoint, depending on what they give us. So if they gave you a line and they told you it's a segment bisector, you would say it's the definition of a segment bisector. If they gave you a midpoint and they told you it was the midpoint, you'd say definition of midpoint. All right. What about, let's say I had an angle and then a line that cuts through that angle, but it creates two congruent baby angles. What's this line called? If it cuts that angle into two congruent baby angles. So a line that cuts another angle into two congruent angles. What's that called? I'll give you a hint. It relates to what we just did. It's a bisector. What type specifically? Angle bisector. And remember, all an angle bisector is just a line that cuts an angle in half. So we can say that angle 1 is congruent to angle 2 because that's the definition of an angle bisector. Now, remember, if we're trying to show congruent triangles, all right, we would say that triangle whatever is congruent to triangle whatever. And it would be by SSS, SAS, angle S, ASA, or HL. So in other words, you would have to show it by one of those congruent postulates. And then once you prove congruent triangles, so let's say we already proved that these two triangles are congruent. Let's say A, B, C is congruent, boys, to D, E, F. I can then say that angle 1 and angle 2 are congruent. I can also say that BC is congruent to EF. Because of CPCTC. So corresponding parts of congruent triangles are congruent. That's what CPCTC stands for. And remember, you can only use CPCTC after triangles are proven congruent. If you haven't shown the triangles are congruent, CPCTC should not show up in your proof. So these are just some very basic reasons and statements that you will see when we do some proofs together. So again, CPCTC is just an acronym for corresponding parts of congruent triangles are congruent. It's on the other side of that graphic organizer. Crap. Any questions on the different statements and reasons? You
Sorry,
three
Miss
okay?
Murphy does that sometimes. I have no idea. Florence,
All right. Let's go through the other graphic organizer really quickly and then we'll take a break. All right, so look at the other graphic organizer. This one's pretty short. So I would still keep out that gold graphic organizer because it's a good reference for what we're doing now. So in Math 2, all right, like I said earlier, you guys should have done proofs in Math 2, but the only proofs that you dealt with were triangle proofs. So typically you were just proving that either parts of triangles were congruent or that two triangles were congruent. Now, quadrilateral proofs are a little different. We're not proving that two quadrilaterals are congruent. We're trying to prove that a quadrilateral is a certain subtype. So we're trying to say that a quadrilateral is a parallelogram or a rhombus or a rectangle or a square or whatever. And the way we do that is to prove that at least one of the following for each kind of subset is true. So for example, with a parallelogram, you would prove that both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, one pair of opposite sides is congruent and parallel, the diagonals bisect each other, or both pairs of opposite angles are congruent. All right, so any of those, if you can prove that, you show it's a parallelogram. All right. With a rectangle, the easiest way is to show that either the diagonals are congruent or all the angles are congruent, meaning they're all 90 degrees. Or it's a parallelogram with one right angle. Because if a parallelogram has one right angle, it's automatically a rectangle. With a rhombus, you want to show that it's either a parallelogram with two congruent consecutive sides. So not the opposite sides are congruent, but the consecutive, or the ones next to each other, are congruent. Or the parallelogram, the diagonals are perpendicular, or all four sides are congruent, or the diagonal bisects opposite angles. And with a square, you either show that it's a rectangle with consecutive congruent sides, or it's a or it's a rhombus with a right angle. All right. Now, we're not going to get into those today. We're mainly going to get into those tomorrow because I want to review triangle proofs first, because that will help when you do the quadrilateral proofs. Some of that stuff will transfer over. All right. Now, the two types of proofs. You've probably seen both of these before. The two types of proofs we're going to deal with, it's pretty much the exact same thing, just different format, is the two-column proof and the flow proof. So a two-column proof is pretty much exactly what it is. It's just your statements are on one side, your reasons are on the other. So you would state your statement and then state the reason next to it. And you just go down the line, almost like a list of what you need to state in the correct order. So in other words, everything connects. So if this is a midpoint of this, that means this is true, and so on and so forth. The flow proof is more of a visual. So the way a flow proof works, it's like a flow chart. All right, so it literally shows the connection. So a lot of people like flow proofs because you can see the connections. All right, so for example, your statements are usually in the bubble. So these right here are your statements. And your reasons are typically written underneath it or outside the bubble, whatever. But if you look, they all correspond or flow at the end to what you're trying to prove. So whatever you're trying to prove is always going to be your last statement of your proof. So they ask us to prove that those two triangles are congruent. That should be the last statement of your flow proof. And it should be the last statement of your two-column proof. Now, in this class, I don't often ask you guys to do proofs from scratch because it can be pretty difficult. Even for honor students, they're a pain in the butt. Even for me, they can be a pain in the butt. Just because with proofs, you literally have to cover all your bases. You got to assume that whoever's reading this has no clue that a side that's the same side, like it's literally the exact same side between two triangles, is congruent to itself. Logically speaking, we know that's true. But with mathematical proofs, it's literally saying if we had to explain this to someone that has no clue about anything logic or common sense, we have to state the obvious pretty much. All right. And with proofs, it's a lot about the why. All right. So most of the time in math with y'all, it's the what. So like what is x equal to? What is the square root of whatever? Things like that. Well, now we're talking about the why. So why are these triangles congruent? Why are these segments congruent? Why are these angles congruent? Why is this a parallelogram? That's what proofs do. And again, they can be a pain because a lot of times people have issues with where to start and where to go next. But I want to show you tricks for that. All right, now look at the back. So on the back is kind of an example. There's two examples of a flow proof. So the first one, they already gave us the statements. All right, we just have to state what the reasons are. So first things first, whenever you look at any proof, the first place your eyes should go to is your givens. All right. Typically with any proof, they have something that's given to you, so you have a place to start. All right. So I always like to mark on my picture what the givens are. So they said that angle H is congruent to angle E. So I'm going to mark those. And segment UR is congruent to segment US. So UR is congruent to US. I then look at what they want us to show so I can kind of figure out a plan of attack. So they want us to show that those two segments are congruent. Now, if you look, that's your last statement. Now, whenever you start a proof, you always start by stating your givens. And the reason for them is literally just given. There's no fancy reason. They just gave it to us. That's all we have to come up with. Now, the route that they're going for is they're trying to prove that these two triangles right here are congruent. All right, because remember, if we can prove that the two triangles are congruent, what can we say is the reason for this last one if we prove the two triangles are congruent? So remember what I said, when you prove two congruent triangles, that means any part of them can be proven by what reason? It's literally the last reason on that yellow sheet. CPCTC. So this last region should be CPCTC because we're showing those triangles are congruent first. Now, they then gave us that HUR, so this angle right here, is congruent to EUS, so this angle right here. Now, that was not in our given, but it is an obvious set of angles that we can say are congruent. Why can I say that those two angles are congruent? What's true about those two angles that I marked with the double lines? Not reflexive. They're vertical. And what's true about vertical angles? They're congruent. So we say vertical angles are congruent. Now we have enough information to state that these two triangles are congruent. And based off of what I have marked, what postulate lets us know that those two triangles are congruent? So is it side, angle, 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 side, side, side? What do you guys think? Based off of what I marked. Close. Angle, side. So remember, the difference between angle, side, angle, and angle, side is if it's angle, side, the side would be between the two angles. If it's angle, side, the side would not be between the two angles. It's only next to one of them. So this is by angle, side. Which from there we can show that that's congruent by CPCTC. And if you look, this showed an angle that's congruent. This showed a side that's congruent. And this showed an angle that's congruent. So it either had to be angle, side, angle, or angle, side. That's why I always say mark what's on the picture, so you can get an idea of which one's which. Now, that was one where they already gave us the statements. Let's look at this one where they didn't give us the statements or the reasons. All they gave us was what was given, and they kind of gave us an idea of what it's going to look like. So they said that angle UQA is congruent to angle DQA. So UQA, so this angle right here, is congruent to DQA, so this angle right here. Now, what will be the reason for that down here? Given. It's in our givens, so it's given. They then said that angle DAQ, so DAQ, so this angle right here, is congruent to UAQ, so this little angle right here. And what's the reason for that one? It's given. So in other words, guys, if it's in your given section, you mark it as given. Now, it wants us to show that angle U is congruent to angle D. So whatever they're asking you to show, that's always your last statement. So angle U is congruent to angle D. We don't know the reason yet, but if we were to take a guess, what do you think the reason's going to be? If you don't know yet, that's fine. All right, so let's look at a plan of attack. So logically speaking, if I'm trying to prove that a piece of two different triangles are congruent, what would be my first step? I need to prove what first? So my end goal is to prove that this angle right here is congruent to this angle here. All right. So 2 different pieces of 2 different triangles. So this triangle and this triangle. So if I wanted to prove that 2 pieces or corresponding pieces of 2 different triangles are true, what would I have to prove first? So if I want to know the pieces are congruent, I got to first know that the what is congruent. So guys, let's say I had 2 dogs, the exact same size and everything. So same size feet, tail, head, height, whatever. So if I know the dogs are congruent, I can then say that their tails are congruent. So if I wanted to show that their tails are congruent, I first need to show what is congruent. Their bodies, or the whole is congruent. So if I want to show that pieces of a triangle are congruent, I first need to show what? The whole triangles are congruent. So that's my plan of attack. I need to show that those 2 triangles, the yellow and the green, are congruent to each other first. All right. So I already have 2 angles that are shown congruent. So based off of my postulates, what are the only 2 postulates that have 2 angles in them? So SAS, SSS, ASA, AAS, HL. Which are the only 2 postulates that this could be congruent by? Guys, come on. 2 angles that are congruent out of all of your postulates. Which 2 could it possibly be? Like, actually say the name. Guys, congruence postulate. So the triangles can either be congruent by what 2 postulates? Angle side angle is one of them that could be congruent by. What's the other one it could possibly be congruent by?
Angle side side.
Nope. No.
Side angle side. Yeah.
Guys, out of all of these, which one has 2? No. Out of all of the, listen. Guys, shut up and listen real quick.
Yeah.
Out of all of these postulates listed, which one has 2 A's? Which 2? Angle side, and angle side angle. So we have to prove it by one of those 2. All right. So if I look back over here, in other words, if I have 2 angles automatically prove congruent, I need to prove what is congruent. An angle or a side?
Side.
A side. Good God. So if you have 2 angles that are already shown to be congruent, the only thing left you have to prove is a side. Now, what is the only side that I know for a fact is congruent? QA. Why is QA congruent to itself? What's it called? Nope. Reflexive property. So we can now say that QDA is congruent to QUA. And based off of what I marked up top, what postulate? ASA or AAS? So is the side between the 2 angles or angle side angle? So in other words, the side is between the 2 congruent angles. So guys, take a minute before you actually talk and let your brain think first before you just spit out something that comes out of your mouth. So that means that we can show that these 2 angles are congruent by what? We already proved that triangles are congruent, so what's the reason that those two angles are congruent? CPCTC. All right, so listen, boys. All right, I'm gonna give you your 3-minute break. Don't move yet. When we come back, you're going to need to have Delta Math open on your Chromebook and have that white packet that you grabbed earlier today out. All right, so I'm going to set the timer for 3 minutes. Go ahead. So 5 seconds. I think I need to go get myself.
No, can you develop in there? I was in Excel, bro.
Guys, go ahead and plug your Chromebooks. Get Delta Math pulled up.
Oh my God. Kirby, you're not even taking off. You should I've been working on something. I've been hurting.
So you guys need Delta Math pulled up, and you need that packet. All right, so let's get back to it. So you guys need Delta Math pulled up, and you need to have the one that's labeled. Need the one that's labeled 5.2 Intro to Proofs. Now, you're going to want that packet that you grabbed at the beginning of class today out, because I basically printed off this entire Delta Math for you guys just so you have something to actually write on to mark the pictures and stuff. Because it can be kind of hard when you're not actually put pen to paper. So my recommendation, take some notes on that paper, but also at the same time put the stuff into Delta Math. So once you get there, click on the very first one. It'll be number 1 on your paper. So it looks like this. So it's 5.2 intro to proofs. We're doing the very first one together. Yeah, very first one. All right. So what we're going to be doing is they already gave us all of the statements. And then we just got to put in the reasons. So the great thing is that anything that's already marked in Delta Math, so if they already marked something for us, our reason is given. All right. So BAC is congruent to DCA. Well, let's see, BAC, so this one right here is congruent to this one right here. Since it's already marked, we can just select the reason to be given, just automatically. Same thing for these two. We can just select it to be given because it was already pre-marked for us. Now, what about this one? So they said that AC is congruent to AC. So why can I say, boys, stop talking. So why can I say that that side's congruent to itself? Yep, it's a reflexive property.
So would you say given or you say reflexive?
Reflexive property. Because it's not given to us, we would say why we absolutely know that. So your reasons in order should be given, reflexive property. Now, if I come back and look at this, so I got these two angles are congruent, and these two angles are congruent, and this side's congruent. I can now say that the two triangles are congruent by what postulate? Okay, so first off, guys. Okay. First off, how many angles are proven congruent between each triangle? 2. So that means it's either going to be angle side or angle side angle. Where's the placement of that side? Is it between the two congruent angles or only next to one of them? It's only next to one of them. So which one does it have to be? Angle side. So this is congruent by angle side. And then you can hit submit. So guys, that's how you go about these. Now, this was one where they already gave you the reasons. Not the reasons. They already gave you the statements and you had to come up with the reasons. But that's not always true. All right, so let's look at the next one. So just hit next on yours. I have to pull up something different. Now, make sure you read the top. So it says up here that AC bisects angle BCD. And they also said that these two sides are congruent and these two angles are congruent. All right. So they already kind of gave us an idea of what our proof's going to look like. And they already said that we're going to be proving by angle side. All right. So we're going to show these triangles are congruent by angle side. Meaning what? How many angles do we need to show that are congruent?
2.
How many sides?
1.
1. All right. So you always start by listing your givens. So first off, we're going to list our first given, which is AC bisects BCD. Now, we need to figure out where to put it. So given that piece of information, do you think that that statement is going to lead to another statement, possibly a congruency statement? Or do you think it's just going to immediately lead to the triangles being congruent? What do you guys think? It's probably going to lead into another statement being congruent. So we're going to pick our type of statement, and that is this side bisects this angle. So XY bisects X. Click on it, it'll give you this. And we're literally going to type in what they had up here. AC bisects BCD. So AC bisects BCD. And why is that true? They told us. It's given. We're then going to list our other givens. So what's one other, oops. So what's one other given here? So what's marked on the triangle already? So guys, what's marked as congruent in other words? So guys, what has tick marks on it? AD is congruent to what? Right. So I'm going to say that two segments are congruent now. And I'm going to say AD is congruent to AB. Why? It was given to us. It was already marked. Now, what's our last given? We already got that. So guys, how do I say this right here? Remember, we name an angle with how many letters? 3. So what is this angle? Nope. CAB is congruent to what? Good. So we would say that two angles are congruent. So angle X is congruent to angle Y. We'll say CAB is congruent to CAD. Why? It was given. Now, the last thing that we need is, so we've proven that a side's congruent and an angle's congruent. So out of angle, angle, side, what would be the last thing we have to prove is congruent if we've already shown an angle? Now, we know it's going to relate to our first given statement, which is AC bisects BCD. So if I look at my picture, if AC bisects this big angle right here, so if it bisects that big angle right here, what's true? What does it mean to bisect? It cuts the angle in half. So that means that, wouldn't that mean that these two baby angles are congruent? Yep, that's exactly what we would say. So we would say angle BCA is congruent to DCA. And the reason is because of the angle bisector. So an angle bisector divides an angle into two congruent angles. And then we got our proof. So guys, that's the thing with proofs. Some statements will lead into another, all right? So that's why with flow proofs, there's a connection. So if we said that this segment bisects this angle, that means that those two baby angles up here are congruent because that's the definition of an angle bisector. All right. Any questions on that one? All right, go to the next one. All right, so this one we're actually having to do on our own. So let's look at this. So I'm going to look at the picture on my sheets. This is number 3 on your packet. First things first, they told us that BC is parallel to AD and AB is parallel to CD. And they want us to show that angle B is congruent to angle D. So let's look at this picture here. What do these arrows mean again? We talked about this last week. Nope. That's tick marks. Arrows mean what? So guys, we talked about this last week. Arrows on a side mean that those two sides are what? Parallel. All right. Tick marks, so they look like that, means congruent. Now, they want us to show that this angle is congruent to this angle. So in other words, if we want to show that two pieces of a whole are congruent, that means we first got to show what? So method of attack. Ignore that it's a quadrilateral. In reality, what is it? So what shape do you it's two triangles. So this triangle and this triangle. So someone besides Dylan, method of attack, we'd first have to prove what before we can say that angle B is congruent to angle D. So before we can say angle B is congruent to angle D, what do we have to show first? Big picture, guys, overall, what do I have to show first? Why do I care about those two triangles? What do I need to show first? So in other words, if I want to prove this by CPCTC, I first need to show what? What does CPCTC mean, guys? What's that acronym stand for? It's on your paper. Look on your yellow paper. What does it mean? Corresponding parts of congruent triangles are congruent. So if we're trying to prove that corresponding parts are congruent, we first need what? What does CT mean? CT. The CT and CPCTC. We need to show the triangles are congruent first. So we got to show that triangle ABC is congruent to triangle DAC. So we got to show that those two triangles are congruent first. Now, let's just go off what we know. So what is one piece of those two triangles that we can flat out say they are congruent right off the bat? Like it's really easy. We know for a fact they're congruent. So the yellow triangle and the green triangle. What piece can we flat out say is automatically congruent? Like we have no question about it. We know for a fact that piece is congruent. It's either a side or an angle. What do you guys say? AC. We can say AC is congruent to what? AC. So first things first, we can say that we want two segments that are congruent. AC is congruent to itself. If someone besides Dylan, what property is that? If something's congruent to itself, what property is that? Reflexive. Now here's the great thing. If you hit try and it takes it, you're correct. If it doesn't take it, you're incorrect. And if you look, they actually marked it on the picture now. Now, let's think about what they gave us originally. So they told us that there's parallel lines here. Why do you think we'd want to know that the sides are parallel? What do we associate with parallel lines a lot? Corresponding or their... What are some things that relate to parallel lines? What theorems? Specifically, if we're dealing with congruency, what's typically shown congruent with parallel lines? So in other words, if I actually drew the lines out, this would be a transversal. What's typically shown to be congruent with parallel lines? So guys, if I gave you something that looked like that, what part would I ask you to prove congruent, an angle or a side? Look at your gold sheet.
Angle.
So angles. Look at your gold sheet. So your geometric proof statements and reasons. What are the only two that dealt with parallel lines cut by a transversal that I gave you? So on the front of your gold sheet with that table. What are the only two reasons for parallel lines? Specifically the one that deals with the congruency. What are we looking at? So guys, everyone should be looking at this sheet. It's too quiet in here. Look at your sheet. Everyone, I want everyone looking at that gold sheet right now. Right. So if I'm looking at parallel lines, all right, these two are both parallel lines cut by a transversal. I'm looking for congruency because I'm trying to prove triangles are congruent. The only one that's listed here is alternate interior angles. Now let's go back to the picture. Is it not true that I got alternate interior angles there? Where? What two angles are alternate interior? Nope. BCA is one of them. What's the other one? DAC. So we can say that those two angles are congruent by alternate interior. So we can say angle BCA is congruent to angle DAC because parallel lines cut by a transversal form congruent alternate interior angles. Now, the same can be said for another set of parallel lines. So there's another set of alternate interior angles. Where are they? Not ABC. BAC is the other one. What's the other? DCA. Good. So we can say those two are congruent by alternate interior angles. So guys, this is what you need to think about. If they gave you parallel lines, why would they give us that to begin with? That's when you want to look at your statements and reasons on your graphic organizer and be like, okay, so what's the only two that deal with parallel lines? What am I trying to prove? So what am I looking for? All right. If the only thing that deals with is alternate interior angles, you're looking for alternate interior angles. So I'm going to say that DCA is congruent to BAC. And it's by the same reason. So parallel lines cut by a transversal. Really? That hit me. Boys, throw something again, see what happens. All three of you will go to ALC. I'm not kidding. Grow up. All right. So we now have two angles and a side that's congruent. So now can we say that the triangles are congruent? Yes or no? Yes, we have two angles and a side that's congruent, which could form one of our postulates. So we can say that ABC is congruent to, CAD. By what postulate? So what's marked here? So here's the congruent side and our two congruent angles. So it's angle side angle. And A, B, C. Oh, it's CDA. You gotta make sure that you write the congruent parts in the right order. So now we proved that the triangles are congruent. Now what can we say? Angle B is congruent to angle D by what? What's the acronym? CPCTC. Then all I gotta do is submit it. All right, any questions on that one? All right, let's do another one. So the next one. All right, this one's pretty straightforward. So they already gave you everything. All right. So we're essentially just listing what they already marked for us. So we're trying to prove that JH is congruent to VX. So we're going to have to prove what's congruent first. So before we can prove that pieces of the two triangles are congruent, we first got to prove what? We've done this like 10 times already. We first got to prove that the triangles are congruent. So let's start by stating what we're given. So someone tell me something that they already gave us. So WV and IJ are congruent. Yep. So WV and IJ are congruent, and that's just because it was given to us. What else did they give us? WX and IH are congruent. Again, it's just given. What's the last thing they told us? What type of triangles are these? So we can actually classify these triangles. So if we hit classify triangles, we're saying that WXV and IHJ are right triangles. Yeah, it's given. Because the 90-degree angle is marked. Now, we got enough to prove the triangles are congruent. So I can go ahead and say that triangle WXV is congruent to IHJ. Why? What postulate? So, guys, if it's a right triangle, it's probably what? Hypotenuse leg. The hypotenuse is congruent for both, and a leg's congruent for both. So it's HL. Thus, I can now say that what I'm trying to prove originally is congruent. So side JH is congruent to VX because of CPCTC. You guys good?
Yeah.
All right. So take a minute. Try the next one on your own. I lied. Don't do that one on your own. Do the next one. Yeah, try the next one on your own. That one's not hard. Just give it a try. Give it a shot. I'll give you guys a couple of minutes. Just give it a shot. So, guys, I'll help you figure out where to start. First off, look at your givens, okay? And look what you're trying to prove. So, you're trying to prove triangle congruence, all right? So, kind of think about a plan of attack. So, if you're trying to prove that BEC, so I think this is 6. So, if you're trying to prove that this triangle is congruent to this triangle, they already gave you a side that's congruent. All right. Think about something that you could automatically mark that's congruent. And then think about why they gave you parallel lines.
It's gotta be the interior thing.
Yeah, so there's some alternate interior angles. So think about alternate interior angles. And also think about what's another angle that you could probably say is congruent. Yep. And think about why. All right, so give it a shot. So guys, when in doubt, the first thing you do is just start by stating that you absolutely know. So if you recognize you got some vertical angles, those are automatically congruent. If you recognize that you have parallel lines, you're probably dealing with some alternate interior or same side interior. Alternate interior specifically if you're dealing with congruence. Reflexive properties, you want to label those too, even though there's not any here. But if there was, you could label that as well. So everyone should be giving this one a shot. How you guys doing? Okay, so at least let's talk through this. All right. So we're trying to prove that these two triangles right here are congruent. We already got one side proven congruent, and we know that these two sides are parallel. So we know we're going to have a postulate that at least contains one side. In my opinion, angles are easier to prove congruent than sides unless it's a reflexive property. All right? So if I'm looking at this picture, what is one set of angles within those two triangles that I can automatically say are congruent? So what are two angles that I can just look at and know for a fact they're congruent? I already marked them. BEC and AED or DEA. So we would say that angle BEC is congruent to DEA. Because what are they? What are those two angles to each other? Nope. They're vertical. Now, speaking of alternate interior, that brings up the whole parallel line thing. So if we're talking about these two lines being parallel, so the transversal would be right here. Which two angles can I say are congruent now? So parallel lines, guys. In other words, if I'm looking for parallel lines within a shape, the only thing I'm looking for is what? Inside parallel lines, congruent. What's the only type that works? AI. What does that stand for? If you look at your gold sheet, guys, what's the only parallel line postulate that I gave you that gives you congruent angles? Alternate interior angles. So what angles are alternate interior? So it'd be DAE, because we're just looking within those triangles. And then BCE. So those are the two angles that we can show are also congruent. So angle DAE is congruent to BCE because of alternate interior. So now I got enough information to show that those triangles are congruent. So I can now say that triangle BEC is congruent to triangle DEA. Why? What postulate? So I got a side and two angles. But look at where the side is. No, it's not. Angle, angle, side. Yep. So guys, you gotta know how to do this. And these, we're not even in the quadrilateral ones yet. Oh, if you actually pay attention, stop screwing around. All right, we got time for one more. Oh, yeah. Let's go back to the one that I skipped. So this one. So the one that looked funky that I was like, let's not. All right. So this is one that where you definitely want to look at the picture that's on the worksheet. So we're trying to prove that BEA is congruent to FDG. So we're trying to prove that this angle is congruent to this angle. Now this is going to take a little finagling. All right. So this is going to actually talk about similar triangles. So we're going to want to show first, I'm going to give you a little help with this, that this triangle is similar, not congruent, similar to this triangle. Because all similar means is that the angles are congruent, but the sides are not, but they're proportional. All right. So first things first, we already got our givens, which is AC is perpendicular to BE and AC is congruent to CG. Now, what can we say about perpendicular? What does that mean for those angles? If they're perpendicular, what does that mean about these two angles right here? They're what? So ACD, what type of angle is this? Oh, it's a right angle. So that's the first thing I'm going to do. I'm going to classify. So ACD is a right angle, and it's because perpendicular lines form right angles. I'm going to do the same thing for this smaller angle right here. So I'm going to classify it as a right angle. So ABE is a right angle because of perpendicular lines. Now, I can then say, since I know they're right angles, because even though they said they're perpendicular and we know that they form a right angle, and they're already marked as a right angle, we had to show that they were right angles first. But now I can say that these two angles are what? So if they're both right angles, that means they are what to each other? Congruent. So I can now say ACD is congruent to ABE. And it's because all right angles are congruent. All right angles are always 90 degrees. Now, I can then show that one more angle between this small triangle and this big triangle is congruent. Which angle? Does the two triangles share an angle?
Yes.
Angle A. So I can say that angle BAE is congruent to CAD because of the reflexive property. Now I got enough information to prove that the two triangles are similar. Where is it? Nope, that won't work. Of course. Triangles are definitely not congruent. Okay, guys, we're going to put a pin in this one. We'll come back to it tomorrow. So go ahead and pack up.
Yeah.
Say that those other two triangles are.
Yes.
There's like meetings.
No weird moves that are like you that bounce around there. I mean, you haven't had to pour water in zero. I did not go to races.
There's a hundred.
I literally saw French people. Yes.
No.
Guys, make sure your boards are erased as well. Bye, guys. I'll see you tomorrow. You too. Those are done.